Hello everyone, welcome back to Explore Electronics. In this video, let's see the derivation for inverting and non-inverting amplifier using Opamp. So here let us see the circuits and also the waveforms. So first let me take Opamp Inverting Amplifier. So Opamp Inverting Amplifier is a kind of amplifier circuit where, as the name itself says, output will be the inverted version of the input what we are going to apply. So first let me write the circuit. So this is the Opamp symbol, minus plus indicating the inverting terminal and the non-inverting terminal. Always Opamp will be having a resistor to the inverting terminal and there will be a feedback resistor which is connected to the output from the inverting terminal. Since it is connected to a minus terminal, you can see this is the negative feedback. And let me call this as R1 and the feedback resistor as RF. And since it is an inverting amplifier, we are going to give the input Vi to the inverting terminal and the non-inverting terminal is grounded. And we are going to measure the output V0 across this terminal with respect to ground. Now, to derive the expression for V0, we need to take the currents into account. First, let me take the current flowing through R1 as I1 and similarly current flowing through the resistor RF, that is IF. And to get the current I1, we need to take the voltage across R1. So for that, let me take this point as A and the voltage at that point as VA. So first let me take the current flowing through R1. So current through R1 is, what is that? Current through R1 is I1, which will be equal to Vi minus, that point is VA, this is point VA, divided by the resistor value, that is R1. Here we need to understand one thing, that the voltage present at VA will be equal to the voltage present at the non-inverting terminal. So what is the voltage at the non-inverting terminal? The non-inverting terminal voltage is 0 since we have connected to 0. That's why VA becomes 0. This concept is called virtual ground concept. Virtual ground concept. Because of virtual ground, we are taking VA as 0. Now if you substitute over here, I1 becomes Vi minus 0 divided by R1. It will be equal to Vi divided by R1. This is I1. Now let me take the current flowing through RF. So current through the feedback resistor, that is RF. What is that current? IF will be equal to VA. From this point to this point, we need to measure the voltage across RF. So IF is equal to VA minus V0 divided by RF. This is the current. Again here VA will be 0 because of virtual ground. So IF is equal to 0 minus V0 divided by RF. That we can write it as IF is equal to minus V0 divided by RF. Here this is one expression for I1. This is the second expression for IF. So, and one more thing is that the current going into the Opamp will be 0. Means whatever the current flow through this resistor will flow through RF. There is no current flow into the Opamp. Why? Because input impedance of this Opamp is very high. Means the resistance at the input side, if you take, that will be infinite for an ideal case. So there will be no current flowing into the Opamp. That's why I1 will be equal to IF. So we can write it as, we know that I1 will be equal to IF. So let me take I1, that is Vi divided by R1. What is IF? Minus V0 divided by RF. We can take from these two expressions, 1 and 2. Now we need to equate for V0. So let me take to the left side. V0 will be equal to, this RF get multiplied, RF divided by R1 into Vi. This minus goes over here. So the expression for V0 will be equal to minus RF by R1 into Vi, that is the input voltage. This is the expression for V0. Suppose if you want to write an expression for gain of the Opamp AV can be written as V0 divided by Vi, that will be equal to minus Rf divided by R1. You can see over here, gain of this inverting amplifier will be dependent on Rf and R1, and it will be negative. Why it is negative? Let us see. Since we have given the input to the inverting terminal of the op-amp, this inverting terminal is going to invert the input what we are going to give at the output. Means if we are going to give this sinusoidal signal as an input at the input terminal, the output what we are going to get will be exactly reverse to that. Means it will be having 180-degree phase shift. So this is the input signal what we are going to give, and this is the output signal we can expect from the inverting amplifier, and easily we can say it will be having 180-degree phase shift. This is about op-amp inverting amplifier. So let us see the non-inverting amplifier now. So the next thing is op-amp non-inverting amplifier. So now you understood that inverting amplifier will be having an input at the inverting terminal of the op-amp. Now the non-inverting amplifier, since these two are the inverting and non-inverting terminals, we are supposed to provide the input to the non-inverting terminal as input Vi. What about the inverting terminal? It will be having a resistor, and now we are going to connect this to ground. Input is connected to the non-inverting terminal now. That's why it is named as non-inverting amplifier. And you can easily guess the output will be a non-inverted version of the input. And here we are going to provide V0. Okay. So again, let me call this as R1 and this as Rf. Now we need to observe the current direction. How the current direction will be? Since it is connected to ground, the current flowing through R1 should come from this Rf. So current through Rf will be from the V0. So current will flow in this direction, again through this direction. Whatever the current flowing through Rf will be called as If. This If current will flow through this resistor R1. Let me call this current as I1 again. And current into the op-amp will be 0. There is no current. So again we can say current If here will be equal to I1. And one more thing is that this point we treated as point A. So what is the voltage at this point now? Whatever the voltage present in the non-inverting terminal will be same as the voltage at this point. I said it is virtual ground. Now since we have a voltage over here, we call it as virtual short, and the voltage Va will be equal to Vi. That is what the voltage we have at the non-inverting terminal. This is because of, you can call it as virtual short or virtual ground. Okay. Again, let us derive the expression for V0 now. How to derive the expression for V0? First, let me take the current flowing through R1. What is the current flowing through R1? It is I1, which will be equal to, what is the direction of current flow? This is the direction of current flow. So we need to take Va first, minus, it is grounded. So Va minus 0 volt divided by the resistor value, that is R1. So I1 becomes Va divided by R1. This is expression 1. Now let me take the current flowing through the feedback resistor. So current through Rf. What is current flowing through Rf now? That is If. If will be equal to, current will be flowing in this direction now. So we need to take V0 first. V0 minus Va. V0 minus Va divided by Rf will be If. Here what is Va again? Va, we know that it is Vi. So V0 minus Vi divided by Rf we can write. We can also write it as V0 by Rf minus Vi divided by Rf. So let me take this as expression 2 for the currents. Now we know that, as we know, currents If will be equal to I1. What is current If? It is V0 divided by Rf minus Vi divided by Rf will be equal to, what is current? Va divided by R1. Again, what is Va here? It is Vi. So we can write it as Vi divided by R1. Let me write directly Vi divided by R1. Now we need to get the expression for V0. So let me write V0 by Rf will be equal to Vi divided by R1. This minus goes to the right side, it becomes plus Vi divided by Rf now. So V0 by Rf will be equal to, let me take Vi as common, Vi into 1 divided by R1 plus 1 divided by Rf. So let me write over here. Now let me take V0 and take this Rf to the right side. It becomes Vi into Rf. Let me multiply into the resistors Rf divided by R1 plus Rf divided by Rf again. Here this Rf get cancelled. So V0 expression will be equal to Vi into Rf divided by R1 plus 1. So this is the expression for V0. Again, if we take the gain of the amplifier, gain AV will be equal to V0 divided by Vi. It is Rf divided by R1 plus 1. So here also the output will be dependent on Rf and R1 plus 1 will be the gain. If you are going to apply the sine wave as input like this, let me take it as T, this as amplitude Vi. If you are going to apply this from the non-inverting terminal of this circuit, the output will be same with some amplification. This is the output wave V0 with respect to T. Here there is no phase shift, we can say. There will be 0 degree phase shift. The input signal what we have will be in phase with the output signal. In the inverting amplifier, we have seen there is a 180 degree phase shift. But in the non-inverting terminal amplifier, we are giving the input to the non-inverting terminal. You can easily say the output is non-inverting. In the inverting amplifier, the output is inverting. This is about the inverting and non-inverting amplifiers. In the next video, let us see more circuits and derivations on Opamp. Thank you.